Pradeep Reddy, and I am from Aeronautical Engineering branch, and my finite element analysis TikTok topic is the ages of materials. The seven ages of materials. The evolution of humankind is inextricably bound up with our use of materials and tools, so much so that the main prehistoric phases of our civilization aren't named after our linguistic prowess, social interactions, or economic achievements, but by the engineering materials of the age. It's a bias that reflects how many materials have changed society with increasing rapidly, while the Stone Age is reckoned in millions of years. Subsequent ages are counted in tens of millennia and ever decreasing units until we reach the Industrial Revolution, when the introduction of new processes was sufficiently quick for the engineering age to be measured in decades. Many of the materials are the Victorians worked with, especially iron and glass, weren't new, despite new elements on the periodic table being discovered all the time. In materials science, discoveries and processes overlap, reinvent themselves, often finding new applications and solutions to long established challenges. Stone Age. The Stone Age is the first in a three-phase framework of human prehistory. The others being bronze and iron, a phrase coined in the 19th century by Danish scholar Christian J. Thomson, who made the assumption that each period was technologically more complex than with that which preceded it. Today, this is seen as an oversimplification that emphasizes the evolution of technology above other factors such as the development of language, agriculture, and society. The consequences for the Stone Age is that it started 2.5 million years ago, with the earliest ended at around 3300 BC, when bronze was first manufactured in Western Asia, extending to the Neolithic age that brought with it cereal cultivation, irrigation, and the expansion of villages into towns and cities. While stone wasn't the only material of the age, pottery made massive advances, with organic materials such as antlers and bones common. The era is named after the most hard-wearing substance of the time. The advent of bronze metallurgy as the new technology for tools and weapons effectively made this aspect of stone obsolete. Some pictures of Stone Age. Bronze Age. There was a time when bronze, an alloy of copper and tin, was the hardest common metal known to mankind, lending its name to Bronze Age, which occupies the gap between the Stone and Iron Ages. In Europe, though, be around 3200 to 600 BC. Technically, it was preceded by the lesser known Chalcolithic period, when copper metal working was the main technology. The manufacture of bronze is one of the most recognizable industrial process, as it required systematic procedures, the separate mining and smelting of tin, which is then added to molten copper, as copper and tin ores are rarely found together. Early trade infrastructures in raw materials developed, with Cornish tin being exported as far as Phoenicia in the eastern Mediterranean. The benefit of bronze was simply that it was harder than copper, as well as being more ductile and stiffer. As uses for bronze increased, metal casting evolved, resulting in the bronze artifact. Odds also suggest that the material represented wealth in the form of stored value as well as status. Some pictures of Bronze Age, from axe heads to armor. Iron Age, third and last in the conventional sequence of prehistoric technology ages. The Iron Age is by far the shortest, sitting between the collapse of the Bronze Age and as beginning of the recorded history. Although the period gets its name from the widespread employment of ferrous metallurgy and the early evolution of carbon cells for tools and weaponry, iron's emergence as the preeminent engineering material of the era was not ushered by any significant innovations in materials processing. Its rise was more a reflection of the economic conditions created by a series of events in the Mediterranean, leading to massive disruptions in the international tin trade around 1300 BC. Market pressures caused by tin scarcity forced metalworks to search for alternative metals with the plentiful iron becoming the material of the day. The main aim of technologies was how to improve iron by hardening it through physical and chemical process. While there is also evidence that metalworks workers were recycling bronze as cheap steel improved, weapons became stronger, lighter, and harder, with the result that when tin re-emerged into onto the market, it was no longer price competitive as a mass production metal. Iron from quality to utility. Glass age. Glass in its natural form has been with us since lightning first struck sand to produce varieties of fused quartz, which is to say long before humans started experimenting with what is now defined as amorphous solid. Glass can be traced back to 3500 BC when the Egyptians and Mesopotamians started to produce jewelry in the form of beads and the Egypt. Although we have made glass for ornamentation ever since, by far its most important feature in everyday uses can be produced can be to be transparent to light. Although there are a multitude of different types of glasses, they are produced in the same fundamental process, that of melting silicon dioxide at high temperature and mixing it with various additives to create different characteristics such as strength, chemical durability, and color before cooling it to form a new material. Although industrial production of glass can be traced back to the 13th century, it really came into its own in the mid 17th century, 19th century when the float process allowed mass production. The 20th century was to see significant innovations brought to glass production by Sir Alastair Pilkington. One of the most important properties of glass that it can, according to the Glass Packaging Institute, be recycled endlessly without any loss in purity or quality, with the manufacturing from cullets, recovered glass, requiring less energy than it to make from raw materials. Glass beyond bottles, windows, and beyond. Steel Age. Although steel has been known to civilizations globally for up to 4000 years, it wasn't until the arrival of Bessemer process in the mid 19th century that it could be mass produced in industrial quantities. Steel started its journey to ubiquity as a semi precious metal, often produced in a haphazard way in bloomeries, a rudimentary type of smelting furnace. But by the Iron Age, it was an establishment alternative to copper alloys because of its hardness along with its ability to produce long lasting sharp edges. It was vital to the arms industry in prehistoric times when steel was very rare. Such was its value that when Alexander the Great defeated the ancient Indian king Porus, he was rewarded not with gold but steel. Bessemer's invention, which removed impurities from iron via an oxidation process to produce steel, was the catalyst required to set the industrial revolution in full flow. A new breed of entrepreneurs such as Andrew Carnegie emerged to exploit its inexhaustible new material, casting rail networks across continents, building vertical cities in the form of skyscrapers, and rolling out vast quantities of low cost utility items such as cutlery. Steel from skyscrapers to spoons. Aluminium Age. Given that it is most abundant metal in the Earth's crust, aluminium was always going to play a leading role as an engineering material. The problem has always been that it only rarely occurs naturally in a pure metallic form and is locked all away chemically in 270 different minerals. Despite the difficulties in extracting aluminium, it is the second most used metal, with global production in 2016 at 58.8 million tons. Iron currently holds the record at 1,232 metric tons, taken for granted today as the material of choice when low density metals are required, from tin foil to aeroplanes, drinks cans to construction, food processing to machinery components. Large scale industrial production didn't arrive until the late 19th century when the Hall Herald process signaled the start of aluminum smelting. In 1889, Austrian chemist Carl Joseph discovered a method of purifying bauxite to yield alumina. The Bayer and Hella-Hartwig process remained the basis of aluminium production to this day. As for the name, aluminium was adopted in the early 19th century because the "ium" suffix sounded classical. Most people agreed except Webster's dictionary, which listed aluminium from tin cans to outer space. Plastic age. The first man-made plastic was invented by metallurgist Alexander Parkes, who exhibited his Parkesian nitrocellulose compound at the Great London Exposition in 1862, where it won a bronze medal. The first fully synthetic plastic was Bakelite, invented in New York, who also gave us in term plastics. The rest is history, with the material becoming a convenient and economic alternative for just about any engineering material imaginable: metals, woods, ceramics, stone, or glass. Because commodity plastics are cheap, they are ubiquitous in food packaging, most of which has historically been thrown away, and because they have large molecules, decomposition rates are slow. Plastic, from packaging to pollution. Thank you.